Good morning all and welcome to today's Tech Tuesday, and thank you to so many of you for joining us for this rapidly developing technology journey from industry, academia and stakeholder investment communities. We know today we've got many of you, not just from the local region, but also from an international context from our registration, so welcome all. Housekeeping today runs for approximately 75 minutes. We have 3 presentations with open Q&A to close this event. Please use the chat channel to position questions, which we'll select after the 3rd presentation. We make no apologies whatsoever in delivering 3 presentations today because the combination, breadth and perspective from all 3 keynotes will combine to position the future and the value this emerging marketplace offers. So for today's Tech Tuesday topic, we wanted to take both a deep tech dive, balanced with developing tech in this arena for multi-level supply chains and users. The tech press quote, "We will see an increased mergers and acquisitions of micro-mobility operators. The market for shared and commercial autonomous vehicles has now eclipsed that for personal autonomous vehicles, thus the pivot towards robo-taxis and driverless trucks. This will continue with rapid acceleration, investment, pilots, and commercial partnerships in the coming year. The most important trend and prediction for the year ahead in 2021 is the widespread adoption by governments of the policies related to 15-minute cities. One thing is sure, no one can do it alone. Cooperation between the regulator, operators, users, and employers will be necessary to move into an autonomous electric on-demand, shared and connected future. Today, you'll hear perspective on each of these challenges where you as the audience will hopefully glean an insight into the opportunities. This is a high-value, high-caliber growth sector as the IoT, AV agendas become more and more specific to the digital society we operate in. But as you all appreciate, this creates massive legislative, security and government operability issues. I'm delighted we have 3 industry figureheads to provide their insights addressing different aspects of this market sector, whilst considering both the societal need and the emerging technologies and challenges being developed for market. We're going to hear first from Professor John Davies, Chief Scientist in the Future Business Technology Research Practice at BT.
Thank you very much, Linda, for that introduction. As Linda says, I lead a research team at BT very much focused on future business and in particular Internet of Things and the technology and applications that can arise from Internet of Things. So in the next 15 minutes or so, I'll give you an introduction to Internet of Things technology and applications. And then the following 2 speakers will focus much more down on future mobility and related topic areas. So I'm just trying to advance the screen and it doesn't seem to want to advance. Donston, can somebody advance the screen for me, please? Thank you. Okay, so we'll start with a very short little bit of history and hopefully the relevance of that will become clear. I will then give an overview of IoT technology and then move on to look at future benefits and impact. And then, as I say, later in the talk, in the session, there'll be more focus on future mobility as a specific issue. Next slide, please. Thank you. So a little bit of history. On June the 21st in 1948, the world's first stored program digital computer executed its first program in Manchester. And you can see there that it was a huge computer on the left there, took up a whole warehouse and many thousands of valves in that computer. So a massive machine. And what's changed in the last 50 or 60 years or so is, of course, miniaturization. So today we have chips which are thousands upon thousands of times faster, than that warehouse-filled computer. Much less use of power, much smaller and much cheaper. So let's see how that has impacted on IoT. And I think, you know, this miniaturization and this increase in computational power and reduction in cost has really led to the current interest in IoT as an emerging sort of tech phenomenon. So if you think about a typical car these days, even in the simplest car, there's probably 15 or 20 sensors or computers, right up to you know, in the hundreds. So computers and sensors are getting literally everywhere. And here's some examples. Sensors have been in cattle, in running shoes, in all kinds of white goods, in smart buildings, in ourselves, biosensors, heart rate monitors and so forth, and increasingly in industrial plant of all shapes and sizes. So what really is the Internet of Things then? As I mentioned, it's been driven by this ubiquity of sensors and computers right at the edge of the network, embedded in our environment, sensing all kinds of data. And as we've seen, it could be in a running shoe, cattle, vehicles, could be weather data, traffic data, air quality data, all kinds of different data is gathered by these sensors, connected to the internet. That's the network layer, which allows us to talk to the sensors, and that data is then transmitted to somewhere where we can process it. We turn the data into information and we analyze it to deliver knowledge and insight, which can make our businesses or processes run more efficiently and effectively. So we've seen this massive increase in the volume of sensors driven by this miniaturization and falling costs of components. The business drivers of that are things like being able to do more with less or with the same infrastructure, so more intelligent use of existing infrastructure rather than large amounts of capital investment, for example. Sustainability, being able to run our traffic and travel systems more efficiently and effectively, reducing pollution while at the same time improving air quality, safety, and so on and so forth. And the technology drivers you can see there I've already touched on. Connectivity options are much better in the last 10 years or so. Battery life, device cost, and the emergence of AI are all technology drivers helping to drive this IoT phenomenon forward. So let's look at the technology stack, if you like, of IoT, and there are four main layers to this. As I've said, there are on the left there, the key really is the sensors out there in the environment, sensing all kinds of data, lights, parking, soil moisture, and so on and so forth. And then we have a range of technology connectivity options, and different kinds of network are appropriate to the different volumes and velocity of data that you happen to be dealing with in a given scenario. Then we need to gather that data in one place, and this is where the data exchange layer comes in, as a data platform where we can aggregate the data, pull it all into one place, and expose it in a uniform way. So it makes it much easier for people who need to process the data and want to extract insight from the data to access the data they need for their particular application. It kind of becomes an information broker, if you like, one place where you can go and get all the information you need, offering economies of scale and fostering innovation by really lowering the barriers to participation in the IoT ecosystem. And then the top layer, of course, is the applications themselves. So once you've got the data, analyzing the data to deliver different kinds of insights, and these can be all kinds of things: smart street lighting, waste management, smart parking, driver assistance, asset tracking, just some of the examples we've got there. And I'll run through some examples from BT and our customers a bit later in the talk. In fact, let's move right now on to some of the business benefits and impacts of this IoT technology. So we did recently we did a survey of our customers, and we found that demand for IoT solutions has been building in the last 12 months or so. And in large organizations, 43% of organizations have already started some level of IoT implementation. In the SME base, the take-up is a little bit smaller, but nevertheless, it's definitely coming along. And as I've already touched on, the trigger is coming from network evolutions, better networks, smaller and cheaper and lower power devices, and reducing cost of managing the data. So I'd like to run through some business benefits, some examples of where we've used the business within BT. This is one of our own use applications. We have a lot of legacy equipment in our exchange buildings, and temperature and humidity significantly affect the performance of this kind of equipment. Previously, we would have sent manually. We would have had someone go and read things like temperature and humidity in exchange buildings to check that they were in reasonable, tolerable limits for the equipment. Now, with the insertion of an appropriate sensor, we can replace that manual inspection with real-time monitoring, so we can look at it at any time of the day or night, at no manual cost, using the IoT sensors. And this has led to better management of the climate within the buildings, leading in turn to reduced equipment faults. And our estimate is that we've saved several millions of pounds using these approaches. Turning to one of our collaborative projects in Manchester, we were involved in a project called City Verve, where we, working with a company called C-Sense, who supply the lights, we installed it says 200, actually it was 400 ultimately there, 400 of these cycle lights to Manchester cyclists, and they gather a range of anonymised sensor data about the routes taken, the acceleration, deceleration, and speed of the cyclist, even how bumpy the particular road was. And they're also smart enough to flash faster and brighter in high-risk situations. So if they detect fierce deceleration, for example, they will start to flash more brightly and more quickly. So really cool smart bike lights. We took that data, we aggregated it on our data hub exchange that I was talking about just a moment ago. And this really gave us a rich picture of how Manchester cyclists were using the cycling infrastructure. So we could draw maps like this, which showed us cycling hotspots. So the red and yellow areas are where cyclists get slowed down a lot. Blue is where they are traveling more freely. And beyond that, we can also do some quite interesting analysis of infrastructure. So this is two parts of the same road in Manchester. On the left is where they had cycle lanes installed, and on the right is where they didn't. And you can see there the yellow is the northbound cyclists, and the turquoise is the southbound. And you can see there how lane discipline is really good where there is cycling infrastructure, and really poor, frankly, where there are no cycle lanes. And also the average speed of cyclists was 19.4, where this is kilometres per hour, where there were cycle lanes installed, and only 12.8 where there were actually no cycle lanes. So really providing some insight to help investors and city planners understand the benefits of installing those cycle lanes and other cycling infrastructure. Smart parking is another one. Here's just an example also from Manchester, where we can monitor the change in parking usage over time. Again, this can give transport planners and city planners better insight how existing infrastructure is being used. And in some cases, we've seen that this has actually been able to delay infrastructure investment. In other words, the decision was made to try and drive up utilisation of existing car parks rather than invest in what is very expensive new car parking capability. So again, it's about sustainability, and it's about optimising using the resources you already have rather than large amounts of expenditure. So, and I think I've just covered exactly this this slide. So this was the Milton Keynes example, where they deployed 2,000 cameras to cover 13,000 parking spaces, and in fact delayed a decision to invest a lot of money in a new car park. Air quality management, so very much about the environment here. We can map air quality in certain roads and areas, and here on the bottom of the graph there, the infographic there, is the traffic count, northbound and southbound on a particular road in Manchester, and on the top of the infographic is the actual line graph showing the air quality, and you can see how it goes up and down over the course of a day. And what we found is you can correlate the traffic volumes with the air quality, so that if you can see that air quality if you can see the traffic volumes is getting to a point where it's likely to tip air quality into a dangerous zone, as it were, then you can put interventions into the traffic system, such as changing traffic light phasing and digital signage, and move traffic away from that area, and hopefully avoid air quality problems becoming acute. Smart highways, this was something we did with Suffolk County Council, where we put in motion sensors and vehicle detectors on the lighting columns of the street lights, and they were used to detect traffic coming down the road, and the street lights would actually be dimmed if there was no traffic approaching that particular area, so that the lights were on when needed and off if there was no traffic, no vehicles around. And Suffolk County Council estimated that they were saving around 30% of their energy cost savings on that, based on the solution that we were able to deliver. Coming to IoT and transport, here we married IoT and AI technologies to reduce congestion. We used live traffic data from sensors that we put on roads and at traffic junctions, traffic lights, and then we used AI technology to replan the phasing of the traffic lights to try and optimize traffic flows through particular junctions. And again, the the aim there was to reduce congestion and to improve air quality. And what we found was that the AI generated light phasing did indeed improve traffic flows, and the key measure there is the difference that you can see top right. That is 2 hours 15 minutes. That's the total wait time for traffic waiting at that junction. So in other words, there was a reduction from 9 hours to 6, almost 7 hours, a difference of 2 hours 15 minutes, a reduction in the wait time aggregated for traffic at that junction in a particular 12-hour period. So quite a significant improvement there in traffic lights and in congestion problems. Excuse me. So just wrapping up then, data from IoT sources continues to grow very, very quickly. IoT technology is becoming increasingly common. I think there are impacts and applications in almost every industry sector, not least travel, transport, future mobility, and so forth. I think that falling costs will continue to drive growth, as it has done already over the last decade or so. And there are definitely very significant opportunities, which I'm sure we're going to hear more about this in just a moment, in things like future mobility, connected autonomous vehicles, and related areas. So with that, I'll wrap up. Thanks very much for your attention, and I'll hand control back to the moderator, Linda, I think.
Yes, thanks very much, John. And as I said, and for the first presentation for setting the scene for us today for this IoT autonomous vehicles kind of pitch and present. So that's a kind of fairly broad overview from John. And now we're going to move into our second presenter on a very, very specific and critically important area. I'd like to introduce Professor Siraj Shaikh, who is Professor of System Security and currently the Director of Research at the Institute of Future Transport and Cities, IFTC, at Coventry University. So Siraj has a multi-level layer of knowledge and application experience, and again, leading the charge in these very specific areas. So I would like to hand over Siraj's session, as it shows on the screen, is the challenge of cybersecurity assurance related to autonomous vehicles. Over to you, Siraj. Thank you.
Thank you, Linda. I wasn't sure whether you're introducing me or someone else. Thank you for your very kind words.
No,
A burden to
definitely
carry.
you, Siraj.
Okay.
Over to you.
So thank you. So I'll thanks for handing over control as well. I'll see if I could manage the slides as well. I'll try my best using this interface. So just want to follow up on John's comments around IoT. I'll delve into the automotive kind of instance of IoT. So a connected vehicle is essentially an example of a kind of a mobile IoT as such, with the connectivity and everything else and so on. The key thing, following up on once again John's various use cases, which is very interesting, is clearly that you could see that there is a let me see if I could move the slides. Oh, okay. So I think it works. Oh, right. Right. So the one of the challenges with a number of those use cases, and as applications and kind of use cases grow, and of course the nature of those things, as it were, which are connected in some shape and form, is what I would call the three C's, as it were. So one of them is complexity in itself, and vehicles are a great example. I mean, John mentioned as well, are an example of a complex kind of an engineering task where we bring in together a number of kind of embedded control systems and communicating kind of components and so on. And that complexity means it's difficult to kind of reason around and understand if there are any kind of potential threats and how we manage that. The other element, of course, is the connectivity itself, and that is not just the kind of external connectivity that we often think about, but if you think about the internal connectivity and the hyperconnectivity that exists between different components and vehicles and people who are looking after maintenance for vehicles or servicing and and other applications in terms of cellular connectivity and so on. So a number of those kind of connectivity pieces open the vehicle up as well for those for potential cybersecurity threats. And of course, the third thing here is the value of the content. As vehicles become much more personalized and used for various kind of personal and kind of valuable purposes and use cases, then the value of the content increases, and of course the risk and the interest from threat actors increases as well. And so, in a sense, I've just taken a jump forward from John's use cases and just to argue that there are a number of those areas that open vehicles in this instance up, but this could apply to many IoT kind of domains. So we've seen over the past few years a number of high profile media kind of items which talk about some of these problems being manifested in actual vehicles. So examples where the remote locking systems have been weak and they've been compromised. Examples where the wireless sensors for tire pressure monitoring systems have been kind of shown to be weak. Other examples where all the kind of infotainment system elements in very leading brands, have been shown to be weak as well. And so so essentially the question mark over the software and connectivity and the complexity generally has been growing. The example here with Prius, for example, is much more about the software elements than external threat actors. But in a sense, the problem of assurance around software and software driven kind of connectivity and complexity ultimately is there, and so of course it has implications for safety as well, but also then being opened up to to security threats. Here's an example on BMW, where this particular example wasn't about security, but was about privacy of drivers within these vehicles. Whereas these use cases kind of open up, there's a push towards connectivity with commercial vendors and even food retailers, trying to get information about vehicle journeys, so they can understand how long a vehicle have been driven, who's in the vehicle, and whether at a certain service station they could tempt them with certain offers for food and so on. So this is interesting because this shows as to the kind of difficult world we live in, where as technology helps us to kind of liberate and connect and be open with a lot of our kind of digital systems and services and so on, there are these concerns around security and privacy that we just need to be kind of mindful of. So a lot of these, particularly security kind of examples that I mentioned, the threats that I that talked about, the vulnerabilities, what is this problem motivated by, and who's kind of driving this? And this is very important to understand, because this then leads on to interesting, clever solutions for potential innovations and startups and ideas and research programs and so on. But one of them, of course, is around this whole what did I use the word, a kind of a ethical hacking geek community that is just driven by demonstration of raw skill and talent, and that that could be leveraged for productive positive purposes as well, but it's still a challenge for a lot of OEMs and tier ones to manage, because it exposes them. Vehicle theft and damage has always been an issue, and with remote kind of locking systems, wireless locking systems, and other things, and so on, that just expands on the problem. Issues of sorry Examples of kind of financial theft and kind of ransomware, blackmail driven kind of cases have also emerged, where essentially any sensitive data or details of movement and mobility and so on could be used for extracting ransom and so on. There is also the issue of kind of remote surveillance for security, for certain security critical or official kind of officials using the vehicle. And once again, that remote surveillance piece intrudes into privacy, but there could be other more serious kind of problems that may emerge from that as well. So that's something also to consider as to how that potentially serves to exploit some of these interfaces that I mentioned. And of course, finally, beyond just crime, there is the potential for kind of more serious organized crime and terrorism, where some of that attempts to exploit kind of large scale transport and mobility solutions for various purposes. So that's something to kind of consider as well, in terms of this area. Now, the one challenge, of course, and this is what we deal with at the university as well in terms of studying and understanding, is around the risk ownership of this kind of problem. And so very often, a lot of my colleagues would, of course, frame the security problem as a technical problem, a technological problem, which it is in one sense, which I've just highlighted, but also it's fundamentally an economic problem, and that then leads on to, kind of who owns the risk, who who stands to be worse exploited and worse affected. Um, by this. And then of course, how will we change this? So this won't happen, as I say, or as over here Bruce Schneier is saying, is the goodness of their hearts. This will have to be aligned, so either through compliance of certain standards and practices and certifications and so on, but also then through kind of economic interests as well. Now, when we talk about safety, in the IoT kind of automotive space, particularly in automotive space, that's one example where if you were to go out and buy a vehicle, you would see how OEMs would place safety as a competitive feature when they compared with products. So a safer car is a better car, and some companies would even argue that they would charge more for certain safety functions and or charge more for the vehicle because they have certain safety features which are industry leading and so on. So they carry a premium. Security hasn't got to that point yet necessarily, and so the business case for security is still a challenge for a number of reasons, and we don't have time for this today, but we're very happy to deal with that in Q&A. So I think that economic incentive, and kind of liability kind of uh, kind of management and risk ownership, that needs to be very clearly addressed, which is a problem that kind of we're looking at as well. And I'll give some examples of a couple of things we're doing at the minute. But essentially, then we going back to this problem of software complexity, we need to understand who is best placed to manage that cybersecurity risk. Um, for commodity traditional enterprise kind of IT software, um, we want to think, well, we can reflect on who picks up the damage, caused due to a software flaw. And it's remarkable how some of the consumer software that we buy, would shift the liability, well, would not accept any liability for the vendor. And so that's interesting. And how would they manage security in life? And so that's why the whole updating and over there updating is becoming such an important um, feature. Is an important feature for normal enterprise software, but also now for automotive. But if you just think about that from a mass consumer perspective, every time you buy a piece of software or hardware and you get home and you plug it in, and the first thing it does, it just updates it. What it really tells you is that it's probably one of the few industries where you buy something, certainly one of the very few mass consumer industries where you buy something which is essentially out of date at the point of sale. So in a sense, um, that's quite remarkable, but that is what it is. So in the automotive industry, once again, those questions are there as to who's affected by a software security flaw and who's best placed to address that. And this becomes very important, particularly when we are talking about before I talk about autonomous vehicles, just one point to mention here in terms of functional safety and cybersecurity and the differences. With safety, essentially, we are dealing with certain malfunctions or design features that lead us to managing that safety related risk from a functional safety perspective. But that malfunction essentially originates from within an item or within a subsystem and so on, whatever the scope of the system is. For security, the challenge is that threat that you see on the slide there actually originates from outside of that feature. And therefore, that external threat landscape in terms of the threat actors and their motivations and how skilled and advanced they are and how persistent they are, all of that is only so much of it we can manage and we can control. And that's why it's a very different problem fundamentally to safety. But then there is an overlap, of course, because essentially within the security envelope, there is safety within itself, because you compromise safety, an external threat actor compromising safety essentially is a security problem. So so in a sense, it's a different problem, therefore, and it's quite fascinating as to what that entails in terms of the in life elements of products of vehicles as well. So eh, my comment about liability earlier on, and I think so for normal consumer kind of items, IoT things, home appliances, perhaps this wouldn't apply so much. But if you consider autonomous vehicles, and I'm just showing here a SAE level of kind of automation and autonomy for different vehicles. So as you see from level 3 onwards, there is automation and autonomy essentially for vehicles, and so that those green bars is where it gets really interesting, because the control is shifted to some software, or some software and hardware combined driven system. Um, what we see here are essentially questions then as to who's responsible for that um, decision making, driven by software, and also then who's liable if that causes any accidents. So this is an important slide. I mean, I could spend a whole day on this, because it's fascinating as to how we deal with people currently. I mean, the fact that someone could pass a driving test and essentially be given a license to drive the vehicle on the road, it is still quite risky, but we accept that risk. And and essentially people carry that risk, the drivers carry that kind of kind of liability. But how do we do that with software? And who takes that responsibility? And so there are a number of questions that emerge here in terms of software modeling and verification, validation, testing and simulation, and kind of design, and then testing of actual kind of prototypes and actual vehicles, and then of course legal instruments as well, and kind of policy and interventions as well, and a number of those things. So there's a whole series of subjects that we can kind of get into, of course, that we look at. So within the university here at Coventry, we have a system security group, and I'll just conclude with it with 2 or 3 slides here, really, just talking about how we are addressing that particular agenda. And the security group sits within IFDC, which is a research institute that we have. Our core mission is to research for the SSG, for the security group, to research and engineer secure and resilient cyber physical systems, particularly for the automotive industry. And I say engineer because we also do prototype with various tools and kind of components and products as well, but working very closely with our industry partners, so very, very closely. And there are 3 or 4 key areas. So there's a lot of work happening on detection and modeling of emerging threats. There is kind of validation, research into methods and tools for assurance. And so once again, that primarily focuses on kind of software that is looking at either control or communications of cyber physical systems. We do a lot of risk assessment, particularly looking at the interplay between security and safety, because that's still a developing area as to how you manage that. And then, of course, as part of some of this, but also in parallel, we also design and build bespoke test beds, and the testing work is in line with the spirit of the automotive industry as it kind of looks at engineered systems, but it is definitely an area which is continually growing and is of increasing interest. So just to give you some example, so the team is it's a multidisciplinary team, people from electronics, people from computer science, people from system engineering and cybersecurity and kind of theoretical areas, and a large cohort of research students. But before I delve into examples, I just want to just quickly, I'm mindful of time, quickly want to talk about, if I could just have the slide in full, could quickly want to talk about what does academic R&D achieve beyond what industry does. So just a very brief comment in light of what I've kind of laid out as a problem and the motivation there is one. We are best placed to explore some very fundamental propositions and kind of looking at problems from first principles. And so we have that luxury and freedom within academia, but working with industry to kind of help guide some of that innovation, you know starting from first principles, is quite powerful, I think, and has the potential to take advantage of most fundamental insights. We can then also de-risk some of the developments by working with industry partners to do proof of concepts. And so I think that piece is certainly in the automotive and autonomous vehicles and transport industries is hugely important, and we're doing a lot of that, and I'll give you some examples of that. I mentioned the complexity, and I think the modeling piece is very important, because to be able to represent complicated problems in very simple kind of forms and solutions, to then reason and argue, and then validate against certain propositions, is an important step that we do, which a lot of it is not very profitable. It's very costly, and that's therefore, once again, universities are very well placed, driven by industry needs or working very closely with industry, but still carrying that burden as such. And then once things are kind of mature, then the trials and testing piece is very important. And so once again, working with colleagues who are very well versed in scientific rigor, to then apply that to various trials and tests for various performance metrics and so on, could be very powerful. And finally, because we are free from commercial imperatives, once again, we have that luxury and space and freedom to then examine some of the ethical and kind of practice issues and kind of value systems that drive certain trends and design and engineering practices. So in a sense, we as academic R&D kind of centers are very well placed for for enabling a competitive sector, but yet healthy. So we work with competitors, and certainly my group works with competitors, but it is healthy in a sense, because there is this horizontal transfer of knowledge as well. So just to conclude on a couple of examples, we're working with Siemens and a couple of other partners at the minute to build the world's first on-chip in-life monitoring solution for automotive security. So this is driven by Siemens technology that looks at kind of hardware-based analytics, the lowest form of kind of clock step speed analytics, and then kind of we're building the entire demonstrator with them at SSG. And then we're also taking part in a DCMS funded 5G kind of trial to do a teleoperated heavy goods vehicle up in Nissan's manufacturing site up in Sunderland. And so we're doing the entire risk assessment for the entire project, and it's using 5G for real-time teleoperation, so which is quite interesting in terms of novelty as well for doing the threat and risk assessment. And then of course we're doing a piece of work currently as part of the UK's Digital Security by Design initiative, which essentially focuses on certain hardware architectural improvements to kind of address security problems. And our package of the work, really working with the Describe Hub led by Bath University, is looking at the economic kind of value chain and the value proposition that secure hardware could offer. And so this is an exciting piece of work, because it essentially looks at what business case there is and what kind of supply chain resistance there could be to adoption of secure hardware. And we are doing a number of other things, but I think it just gives you an example of the kind of diversity of effort and so on. But I should just mention before I hand over to Tom, of course, is that we're just starting a relationship with colleagues at Conigtal as well, with Tom and Don. And so there are a couple of PhD studentships that are currently advertised. We're happy to put some links to colleagues. They're on LinkedIn, so if you just search my name, you'll probably find them. But that's another example of where you're working with industry as well to solve some critical problems. So that was a very quick, rushed journey. Linda, over to you. Thanks.
No, thank you so much, Siraj. It is a massive topic, and I think you've succinctly kind of covered, should we say, the kind of baseline, and should we say the complexity of this, should we say, emerging technology that needs all these levels of expertise, but also create huge opportunities for many of our up and coming entrepreneurial businesses, but also our existing larger tech companies, where they can diversify and are into this new world space. So thank you so much, Siraj. Very, very critical subject area, and very well delivered. So many questions coming in, and keep the questions coming in. We will really try and filter against our time frame for this morning, but yes, some very interesting questions coming in, so thank you. Now I just want to move over to our third and final presenter, this morning, Conigtal, who are making excellent progress in their early development since their 2015 formation. Conigtal, the connected digital company, has embarked on their mission to disrupt the transport industry through a vision of greener, more efficient mobility for all, and to create democratized autonomy and AI in order to empower society by accelerating the introduction of seamless, clean travel. Here at BetaDen, we're delighted that Conigtal have joined our cohort 4 in April this year and can access through our testbed, the Worcestershire 5G testbed, to evaluate the services as part of their ongoing development and as part of our accelerator here at Malvern Hills Science Park. I'd like to introduce Tom Robinson, who is Technical Director at Conigtal, and his case study he's going to present to you this morning, Connecting the World. Over to you, Tom. Thank you.
Hello, folks. So I'm Tom Robinson. I'm the Chief Technology Officer here at Conigtal, and Conigtal stands for Connected Digital, and our vision is to digitally connect autonomous vehicles to empower mobility for all. And if I can just figure out how to actually change screens. Here we go. Oh, go back. Apologies. So a short video that introduces our business and sets some context. Turn the volume up because you'll like it.
My name is Connie. Welcome to our autonomous vehicle.
Bonjour,
Hola.
namaste.
I like showing that. Every time I watch it, it gets my blood flowing. So it sets the right tone, I think, for the rest of the presentation. If I can now figure out how to get off that page onto the next one. There we go. So one too many again. So in summary, our Conigtal product suite provides a turnkey driverless vehicle deployment and the back-end platform for transport operators to run app-based on-demand mobility services with a driven or a driverless fleet. And that's part of our white-labeled mobility as a service offering. And that consists of ConOp, which is our next generation operational management system, ConAV, which is a lift and shift retrofit vehicle automation platform, ConApp, which is our end user app that includes mass capability, and also Conoptium, which is the foundation of our solution that provides the optimization. And supporting each of those is Connie, which is our interactive speech-based information portal that allows voice-based interaction with passengers. And the mobility as a service ecosystem is a very complex one. And Conigtal is engaged in providing automation and supporting systems that both enable and leverage vehicle automation. And the illustration on the screen highlights some of the complexity of integrated systems with the cyan elements indicating Conigtal's immediate focus. So we understand how automated vehicles, or AVs, can be part of a much larger mass solution to provide the integrated, seamless, multimodal travel that society aspires to. There are significant challenges in introducing vehicle automation, including ensuring they're safe and affordable. And to ensure systems are safe, we need to be able to test them. And a lot of testing is undertaken in a simulation environment, and that helps to accelerate the development, but it isn't a true reflection of the real world. Not all scenarios that will be encountered in the real world will be available as simulations. It is worth saying there is a UK national scenario database that's being defined, which is due to launch in late 2021. I don't believe it's still going to be able to capture all of the edge cases. Automated vehicles are typically being developed with a rules-based solution, but with a rules-based system, it is possible to define clear test cases that have a defined predictable output. However, the rules approach has limitations when edge cases are considered. So AV solutions are being evolved to supplement the rules-based approach with machine learning and other AI techniques to encompass a greater set of edge cases. But the challenge when deep learning is applied is that it becomes non-deterministic and extremely difficult to demonstrate that all requirements are handled as expected. Testing has to be undertaken as a black box with some significant uncertainty remaining as to how the system will actually behave. So corner cases are a problem, particularly in uncontrolled operating domains. Obeying road rules presents challenges for an AV where those rules are hard-coded. A human is able to accept deviations from the rules, but trying to program in all the variations is not viable in an AV solution. You really need to control the domain or add AI. So if you imagine you're driving down a narrow street and it's partially blocked by a car, the only way to proceed is to mount the pavement. A human will most likely make the decision to do that, not all of them, most will. The AV will need to be told it can break the rules. But how do you cover all the scenarios, the must obey rules, and the times when the rules may be broken? There are also a substantial number of variables that a human is able to handle, but the AV is not. The variations can be replicated to some extent in simulations, but a huge gap still remains. I suspect we'll never actually stop training AI systems. Any amount of data will never be enough. We also need to consider training bias. Recent examples have been seen and publicized relating to training bias in AI-based applications. For example, a lamppost with a wide base can be detected and falsely recognized in some systems as a human being, and the AI will process accordingly. I'll let you visualize what training material was used for that particular scenario. Detection algorithms can confuse objects, which sometimes is okay. Other times it's going to be problematical. For example, if you treat a train as a coach, it might be okay when it's not moving, but when it moves, it's going to present some different challenges. It's still unclear how much training is required before you consider the system is sufficiently reliable. And what do we define as sufficient? From a safety perspective, we must be better than humans. I think the bottom line is that categorization and classification needs to be objective, robust, and avoid bias. So the autonomous control system, ACS, is conceptually quite simple, and the functional illustration on the screen shows and highlights the key ACS elements within the circle with supporting elements on the periphery of it. Sensor processing in this diagram encompasses all the sensors, the processing of the sensors, and the fusion of the data to provide a comprehensive understanding of what is around the vehicle. The fused data can be used to undertake object detection and even object classification. The prediction functionality is taking the fused data and providing an internal map for the ego vehicle to use. And this map includes a forecast of predicted behavior for each object. The predicted behavior can use a simple physics-based approach. So in other words, the object is going to continue doing whatever it was doing before, or you can use a more complex approach, and that's assuming you can actually classify the object. For example, you can classify a pedestrian and their orientation, which indicates potentially that they're likely to cross the road. On the complex approach, you can use object-specific models, which is inherently rules-based, or an AI-based approach to predict the behavior based upon training. The system decision-making uses the awareness of the environment around the vehicle, as well as an understanding of the vehicle capabilities and limitations alongside the target's objectives to determine what maneuvers to undertake. This maneuver decision is typically based on some form of cost calculation. The maneuver is converted to a set of driving instructions that are applied by the vehicle control system to instigate change, for instance, steering, acceleration, braking, and even operating of the lights and signals. The safety monitor, which is actually something that might be distributed across several vehicle components, is present to ensure that the system behaves as intended and degrades gracefully in the event that safety is deemed to be compromised. This considers safety interlocks as well as generally monitoring for faults within the system. The data logger is a bit like an aircraft black box. It captures information that may be required for incident investigation or general problem resolution by a development team. Now, the vehicle threats communications provides high-level cybersecurity instructions to the vehicle. For example, go to Coventry rail station, collect Mr. Jones, and drive to Coventry bus station via a defined route. The V2X also, especially with the advent of 5G, can provide a remote monitoring and teleoperation capability for when the exception cases occur that the vehicle AV is currently not able to handle, and there's still quite a lot of those out there. But this must include cybersecurity measures, including those that address the new UN regulation number 155. The sensors themselves have different characteristics, leading to sensor payloads with combinations of sensors. Radar is great for long range. Is very immune to environmental changes such as the weather. It provides accurate pose, which is position, distance, and velocity, but at a low precision. LiDAR is very good in medium range, but it's susceptible to reflectivity and environmental conditions. Its accuracy and precision are both high. It is, however, very expensive at present and pushes up the BOM cost quite considerably. The camera and video processing is very good in short to long range applications, but it's also affected by the environment and can be significantly affected by sunloading. There are a lot of developments ongoing at the moment that are looking at image processing and overcoming those limitations, but that in itself requires some significant processing capacity, which again is pushing up the BOM cost. Different camera technologies can also be applied to overcome some challenges and provide additional information, such as infrared technologies or stereo imaging vision. In terms of positioning, you also need to know where your vehicle is, both in terms that are referenced to the ego vehicle, but also in terms that are relative to other objects and the vehicle's immediate location. The required position accuracy is somewhat dependent on the operating domain and the parameters that you're working to, but typically we're targeting plus or minus 2 centimeters accuracy. And this can be achieved by a number of means, including GPS RTK or SLAM, but these themselves have their own failure modes that do warrant having a redundant solution. To have a reliable perception of the world, you must also fuse the data together. And as part of that fusion, you must also understand the limitations of the sensors to make sure you give appropriate credence to the data sources. The illustration shown on the screen is highlighting how a wet environment could lead to confusion in the perception system. In a video-only solution, the reflections in the water could lead to multiple false identifications of buildings or traffic lights. If you can combine radar or LiDAR with your inputs, you can fuse the data to eliminate those reflections, ensuring only real objects are identified and classified. And that can also be further ratified by the maps that you're using within your system to add further confidence. So an awareness of the vehicle location is paramount in determining what path it needs to follow in relation to its target destination. And generally, the vehicle is provided with a set of waypoints, and it's responsible for navigating between the waypoints to get to the destination. This requires the continual determination of a path, taking into account the 6 degrees of freedom that the vehicle has. In an empty or a highly controlled environment, the path followed can have a direct correlation with the route requested. In reality, along that route, there will be additional control decisions that relate to the environment detected. So a simple example is as traffic signals on a straight road. With no signals, the vehicles can accelerate to the optimum speed, maintain the speed, and decelerate as it approaches the destination. When you add in the traffic signals, you're introducing variation in the speed profile, which depends on the state of the traffic signals and also on the fact that you have to detect them in the first place. You can also add extra complexity by bends in the roads, which are going to affect the target speed profile, the environmental conditions, such as ice or rainy conditions, which affect the controllability of the vehicle, which then warrants you having actually a very good dynamic model of the vehicle that represents its own capabilities. When you throw into the mix other road users, each of which are behaving independently and largely adhering to the rules of the road, but not always, you can see how even a simple operation could become highly complex. Now, the objects identified could be classified as static or dynamic, along with additional information about their predicted behavior. So a traffic light is a static object, can have a changing state of red, amber, green, or it could just have turn left only, for instance. Even a simple thing like a traffic light can have some complexity. The behavior prediction itself is associated with a more detailed classification of the object. So you need to be able to reliably and accurately classify objects using an agreed taxonomy. And especially if you're using maps provided by third parties. Simple example, a lamppost won't move, but a person will. As will a cockatoo. However, a cockatoo, and the reason I mentioned a cockatoo is because we've encountered them on our Australian project, it will behave differently and fly, which you don't necessarily model with a person, unless they've got a jetpack. Identifying and classifying objects around the vehicle allows a dynamic map to be maintained. This is then used to determine the maneuvers the vehicle needs to undertake and when it needs to undertake them. And this is dynamic and changing and requires constant processing. So the illustration on the right shows a number of possible actions by each object identified. In reality, there is a single prediction made by the system for each object, which is used when calculating a vehicle path. However, the simulation video on the left also shows how some objects around the vehicle may be misclassified as cars, leading to different decisions by the ACS. So in conclusion, even relatively simple scenarios such as turning left at a junction can present problems. The simulation on the screen shows the vehicle approaching a junction where there is only relatively late identification of the cyclist. In this example, where the uncertainty is reflected in the vehicle's speed, the cyclist remains safe. Unhandled corner cases are going to continue to remain the fact for a considerable time, particularly in less controlled operating domains, warranting and requiring remote monitoring and teleoperation. This in itself requires an assured cybersecurity and 5G or equivalent capability, hence why we're sponsoring PhD. There are also different vehicle automation applications to MaaS and FaaS, that's mobility as a service and freight as a service, with their own specific challenges. And that includes Industry 4.0, construction, mining, and agricultural applications. However, these have the common challenges of safety, affordability, and testability. I think that's me done, actually. Thank you very much.
Thank you so much, Tom. Again, phenomenal vision and development by Conigtal, and we're very lucky to have you in BetaDen. So thank you so much for that. Now, if we can come off main delivery and come on to our panel for our screen, we can get the Q&A open. I'm sure, looking at kind of the number of questions that have come in, we're going to have a bit of a gallop here. So some quite succinct answers, if we can, please, from the panel, which will be coming through. The one of the biggest questions is about the data. We've got multi-level questions on data and who owns this data. So can I have very short answers across the panel, please, starting with John?
Who owns the data? Well, there's no one answer to that question. We see various scenarios. So we, BT, we've worked with scenarios where the owner of the data is the same person as the person who is benefiting from analysis of that data, so that, you know, the data is effectively in a silo. You know, a company owns the data and exploits it for its own actionable insights. But in a smart city, for example, you've often got multiple data providers and then multiple data consumers. And that's where this notion of an IoT data platform comes in, where you can support different people providing data and different people consuming that data. And the data providers
I'm going to have to press the button. So, as I said, quick, short answers, please. We're against the clock. Siraj, quick view from you on data.
Thank you. I'll answer a different but related question, if I may, which is that it's a complex answer. But if we can work out who owns the data and let the people who are either creating or managing know and be very explicit about who owns that data and how that what the data life cycle is, I think it could lead to a very good a data-led market economy where people could either trade data and benefit in various ways. Equally, it could be commercial or non-commercial offerings that could take advantage, but people would have then trust and transparency, which would lead to confidence in various data kind of sharing and enabled related services. And that's a slightly different question, but it's an important point, which is related.
No, it links to another question about the kind of transformation of the data generated from IoT into a meaningful and common use. So yeah, answers seriously needed for that. Can we just jump across to Tom? Just a perspective on that, Tom. I know it's a big topic area, but a short answer, please, from your perspective.
I think it rather depends on which data you're talking about. If it's personal data, there's different legislation in different countries that affect what can be done and who owns that data. So I don't think there's a simple answer to the question, unfortunately.
Okay, a quick question for John at BT. Do you use third-party software for creating the data lakes and app analytics, or is that internally programmed?
The data exchange that I refer to, the IoT data exchange for providing and consuming data, is a BT platform. In fact, we also work with the big hyperscaler cloud providers as well. So it's a mixture, in fact.
Okay, thank you. A question or a comment for Siraj, please, from Colin O'Halloran from D-Risk. Siraj, safety vulnerabilities have traditionally been mitigated by the remote probability that the environment will not trigger a vulnerability. Security vulnerabilities cannot employ this kind of mitigation. However, now even for safety, the environment mitigation cannot be assumed because malicious actors can trigger a safety vulnerability. Any comment on that, please?
So I think there are interesting architectures that are emerging, and some of them. For example, one concept I'm sure Colin would be aware of, it would be hypervisors, or essentially virtual kind of monitors that are there to then actively monitor the state of the system and to potentially, kind of raise alerts and so on. So we need to look at those advanced architectures and advanced kind of concepts to then be able to kind of, handle that. I completely agree. I think, the way we're losing essentially control of our systems, of our environment, and how, and also the supply chain. If you imagine, in an environment where if you take drones and how the kind of penetration of that across different use cases, and I think drones are a very classic example where the risk is very high in a number of different senses. And so I think we need to look at those advanced architectures to perhaps address that. Very happy to do a follow-up on that. It's an interesting area for sure, both
Certainly.
for safety
Thank
and
you.
security. Yeah.
Absolutely. Thank you so much. Good point made, Colin. Thank you for that. A question from Nick Comley here. How will quantum computing affect predictability and reduce costs of sensors and increase redundant contingencies? Can I ask for a volunteer on that one, please?
I mean, I can have a go. That's a really great question, and I'm not sure anybody actually knows the answer yet, because quantum computing is very much in its infancy. But I think we can expect that some of the incredible processing capabilities that it will deliver will transform IoT and every other area of IT. So yeah, it's a bit of a high level answer, but I think it's very difficult to predict, but it will be significant for sure.
Okay, Andrew Potter from Forge Rock. How do you secure the ecosystem, i.e. ensure devices onboarded are not rogue, devices have verified identities, messages flowing through the IoT network are authorized? So can I pose that to Tom? Are you happy to answer that, Tom?
Yeah, I mean, I did touch on it in terms of understanding and following and adhering to regulation number 155, which is your new regulation for security, and developing and designing your system following those regulations, but also keeping on top of it. I mean, it touches on the previous question, actually, the quantum computing, because if you can actually start to introduce quantum computing to give you real genuine random numbers, then you can apply that as part of the encryption process and apply that into your security stack. Siraj might be better placed to answer this than me.
Do you want to take it, Siraj, or
Can you repeat the question?
Yeah, it came from, let me just flag it again. How do you secure the ecosystem? Ensure devices onboarded are not rogue. Devices have verified identities and messages flowing through the IoT network are authorized. So
if I could just answer that in one instance, in automotive, obviously, the after the market devices just for automotive, we did a piece of research on that, published a couple of papers as well. It's quite fascinating, actually. People go on eBay and you can buy all kinds of apps and so on, and everything else. It's very difficult. We can't even have assurances on supply chains. I mean, organizations naturally are in a free market economy driven by prices, and so if you can save 2p by a supplier, perhaps then you would do that. And so that would raise questions as to how conscious and kind of mindful we are and how we kind of regulate that. So the question is that is an open problem, and it is getting even more complex. And in the case of 5G, for example, we've seen it gets very political as well. So it's a difficult one.
Okay, thank you so much. A little bit left field, but very pertinent to the societal kind of rollout. While it's clear that IoT rollout will be commercially or public sector led, how can charities and VCS organizations access, deploy and use IoT platforms to better engage with communities and deliver remote services, which would have improved and accelerated support during the pandemic? Big question. I need a short answer from just a few, please, if I could. John or Tom, take that.
We're working with the Beacon Institute, is one of our investors. And part of what we're doing with them is understanding how the mobility as a service application with this IoT connectivity can actually support the accessibility and movement of people who have difficulties moving otherwise. That's a quick answer.
It's a quick answer, thank you. And I think we've got time for just one more question, because I'm conscious it's a very deep topic and we could answer questions all day, and particularly with the expertise of the panel. I know many of our registrants today will be frustrated by this, and we may have to return to this topic because, as I said, it's probably too deep to do a gallop at this pace. But I was just looking for an IoT question of the life. So sensors will have a finite life. Whilst it's relatively easy to roll out a system of sensors, the future cost of maintenance of these systems may well be uneconomic. Do you see any moves to have intelligent systems that can deal with a percentage of defective sensors without losing performance? That's from one of our BetaDen mentors, John Forshaw. Could I put that to BT? To John?
Yeah, I think it's a good question. I think one of the key things about sensors recently has been this massively reduced power requirements, which means that you can have battery powered sensors that will be in life for much longer than previously. So that's a real plus. But nevertheless, yeah, there is a cost to they'll have to be recycled. They won't last forever. One of the things we're looking at in BT is something called zero touch onboarding, which essentially massively reduces the manual intervention required to set up sensors and to configure them to be used on the network. So there are definitely techniques and processes coming along that are going to help with that issue, but it is a real issue.
Yes, as I said, again, it's a brave new world, isn't it? And there are so many levels to this. And as I said, I think as BetaDen, we will return to this topic because this gallop through this morning has indicated, even by the numbers of registrants for this event, and to listen to you, our experts as well. So for those of you frustrated by not getting a question answered, I promise that a CEO of BetaDen will bring it back and perhaps kind of break it down into particular kind of subsectors as well, so that we can get the experts on again to kind of cover in more depth some of these quite critical development needs as well. So I'm going to have to close at this point, and obviously a huge thank you to our presenters today. We're very lucky that you've given us this time, and I'm sure our audience appreciate what you've kind of given them a flavour for, certainly, so thank you for that. We close with a reminder that BetaDen's Tech Tuesday series continues in September the 7th, with assistive technologies and remote medicine. And we will have positioning for this specific technology, needs versus social care costs, and the impact the role digital tech can play. Speakers secured so far include Mike Emery, who is Director of Digital Health and Infrastructure for Herefordshire and Worcestershire CCG, and Rupert Lawrence, Head of Amica, who are the new brand name for the telecare service, which again is a company in development, addressing, as I said, societal need versus kind of, should we say, cost of social care. We look forward to seeing as many of you as possible on the next one. And please kind of keep spreading the word to any of your network about BetaDen's Tech Tuesday series. If any of you have any kind of desire to put a topic on and present, again, please contact the BetaDen team at the info@email. Thank you for attending today. If you are local and you want to kind of see some of the BetaDen alumni and companies that are kind of going through our program, we will be doing a pitch and exhibition afternoon as part of Malvern's Festival of Innovation on Thursday, the 7th of October. More information to follow on that. So again, if you want to come and talk to some of these early stage and developing companies, you can get to meet them face to face, which in the world we've lived in the last 15 months is a pretty strange concept. But we hope to see as many of you there that would like to come and join in. And registrations for recruitment for cohort 5 open in October. So again, keep spreading the word because BetaDen seriously is about making tech that the world wants to buy. Thank you again for your time this morning. Really appreciate it. And hopefully hear you very soon. Okay, take care.
Thank you.